Okay, so we're going to go ahead and get started. Over there on the wall we have the objectives, the goals written down under the chemistry section. Right now the time is about 10:02. And yeah.
Self-mutilation time. You guys ready? Chemistry.
I don't even know if she knows.
I'm applauding your skills, Barb. I'm sorry. That was a really good show.
It's so good. Like, I had it. Oh,
After the video is done, could you
Have I eyes on me?
Oh my gosh, is that good?
It's so good.
the one that
It's good, but
with the cards?
like, I'm really a zombie. And it like, makes me mad.
But there's so much snark.
And there is.
And I'm really kind of impressed
So-
with the actress. Like, just she has to keep, because the character changes every episode.
Oh, yeah.
But she keeps up with it. And I'm like, that's so good.
It's buggy once in a while, so you know,
Everybody
you can
else
always do whatever you're trying to do.
Yeah, you're changing every episode.
No, we just got let out of 7 really late, so I was like, sure.
Yeah, just checking.
Okay, so we have actually technology using the tablet connected to the projector, so that'll be really nice.
Tablet takes over the computer.
Yeah, tablet connected to the computer so we can control the projector. And then the remote you have turns on the projector, or?
Oh, I've seen that.
Okay.
Okay.
I want it.
Power one's for on, and then you gotta double click it for off.
That doesn't count. I was like in the door.
Yeah, but you're stopping it.
But then we were both here on time.
No, you kept Nick from entering on time.
What?
You kept Nick from entering on time.
No way. Can we have 2 places to watch? So talented. Oh, I knew that already. I knew bragging rights. She's like, hard skills come with
Yay,
bragging rights.
Connor!
I'm
Brielle! Kenzie!
She's here, but she had to go to the office.
I heard her.
I actually just can't even know if she is here.
No, she's here. She's in my last class.
Angelica! Mariah!
You think I know these things? I do.
Silly! Riley! Chantel! Ezra! Jensen!
The red and
Jensen, you here? Yeah. Camille! Nick! Taylor! Marisol! Mackenzie! Subin! Kelsey! Amanda! Riker!
okay.
Like, why? No.
Autumn! Taya! Nakai! Hey, I'm glad you're here, Nakai.
Like, at least one joke is a fair
Well,
episode.
welcome everyone to
Hey!
another glorious day of chemistry. As you can see over there on the boards, I don't know if you've seen yet, but we have the objectives for today. We're going to be covering chapter 6.1, organizing the elements. And so we're going to be focusing specifically on those 2 goals, developing and using models to identify patterns and trends. Patterns and trends in the periodic table, and then analyzing and interpreting data to be able to use patterns in the periodic table to identify desirable qualities of elements. And so to start off with, let's review very briefly the elements. And if Mr. Reed can get the lights, we'll go ahead and start the video. Right, is that working?
Then the elements of the periodic table.
There's hydrogen and helium, the lithium, beryllium, carbon everywhere, nitrogen all through the air, oxygen so you can breathe, and fluorine for your 3D teeth, neon to light up the sign, sodium for salty times, magnesium, aluminium, silicon, phosphorus, then sulfur, chlorine, and argon, potassium, and calcium so you'll grow strong, scandium, titanium, vanadium, and chromium, and manganese. This is the periodic table, no gas is stable, halogens and alkali react aggressively. Each period will see new outer shell electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel, coins you get, copper, zinc, gallium, germanium, and arsen, selenium, and rhodium, and will krypton helps light up your room, rubidium, strontium, and yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silverware, then cadmium and indium, tincan, antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits. Well, lantern nights have just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62. Samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, terbium, lutetium. Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, barium, and leather is it for your tummy, polonium, acetate would not be yummy, radar, and cesium will last a little time, radium, then acting as an 89. This is the periodic table, no gas is stable, halogens and alkali react aggressively. Each period will see new outer shell electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, diversity, curium, berkelium, californium, itanium, rhodium, nobelium, lawrencium, rutherfordium, barium, spudium, boreum, lithium, magnesium, oxidium, ruthenium, copernicium, natrium, ferrovium, adamantium, livermorium, unactinium, and then we're done. Like the song, be sure to check it out on iTunes and Bandcamp. Links are in the description. And
This is awesome. We can memorize the whole table now.
Let's dine up. My God.
I'm just kidding. That's terrible.
I think you turn the lights back on. Yeah, I'm kind of curious how do I actually do this.
Bottom right.
Bottom right?
Here, I'll just do it.
Yeah. Okay, there we go. Perfect. First time using one of these teaching. So now we'll go to, okay.
Are you doing that from that?
Yep. Okay, so now it's time for some serious sorting. Let's go ahead and turn on the lights. So as you can see with the periodic table, that there was a certain pattern to, or there's a certain shape that the periodic table has. And what we want to learn today is why it has that certain shape. And so to start that off, we're going to do an activity where you're going to be able to do some series sorting. So over here on the lab benches, I have five packs of cards ready and a worksheet that you're going to complete as a group. And so I would like you to break off into groups of 4 to 5 people. And to each find a bench, and you're going to go over there. You're going to open up the pack of cards and you're going to read the directions on the piece of paper. So, go.
This makes me feel good. What are you doing?
There's 2 missing sides.
I'll get up and walk around.
So I can give you some points.
It's 2, 2, and 2, 4.
Better, Mason. That's
So now I'm trying to open books like this.
I'm like
on
halfway
my
through the
tab.
review.
And I recommend you don't get behind. Alright guys, find a home.
Okay, open up the deck of cards. You'll see that on the piece of paper it says that your job is to open them
Find a home, hurry.
and to find as many different ways as you can to organize these cards. Now this is a standard deck of playing cards. Just tell me how you can organize them.
Read the directions.
Yeah.
That's exactly what he said what the directions are. I don't understand like organize them how.
Organize them, like you can do it in numerical order, or you can do it by symbols. So organize them as many different ways as you can. If you can only, even if you can organize maybe like sets of 2, that's fine. I want to know how many ways you can organize these cards.
Find their face.
Okay, so here the students are doing their activity. They're looking at the cards.
Yeah, but I'm worse capable. Well, no, the girls have better. I refuse. I am the dealer, not the author. There you go.
Yeah, whenever I teach.
We could do like
When we write down everything down.
So,
Not just because they're like they were to do it
values.
it's so that I can have a better teacher.
What do you want to do? Like, do you want to be a science teacher?
No, just figure out as many ways as you can. So you got symbols, you got face cards. What about numbers? Have you done numbers?
Yeah, that'd be good. Like Jackson.
Well, face cards are these, so you can organize them.
letters.
You could do it.
So could you do it like by all 2s, all 3s, all 4s? Like that'd be
So
something.
you can do it in numerical order, or you can do it by the same number. So
What would you call the same number?
Just write the same
No,
number.
they put same number on there.
There you go. See? You're getting the same thing.
Design.
No, he just said they're there. Because like if you put all 2s, the pile of all 3s instead of just 1, 2, 3,
Letters.
that would be more. But if you put like all 2s and all 3s and all 4s, it just would be same.
So, $1 back.
So design.
You can see by the cut corner.
Enhance.
Yeah,
Prime numbers against numbers.
Wait, what do you guys mean by design? Like you just start them? Oh, yeah, be fast.
I mean, you got all these stuff far.
What else do you have?
Only way.
Yeah, symbols, space.
And that's the order.
I think that's all you can.
I feel better.
Well, we have to fill it out.
So that you
So you mean the same one. Here we go.
Did you put colors on it?
There you go.
I'm not.
Now let's know we got the
The show is like.
There's probably sort of, well,
I'm curious to see this one. Yeah, that's what I said right there. Right, and like, think any idea is a good idea. Okay, any idea is a good idea. Oh, you don't need to fill all 13. But if you can, I would be very surprised. I'd be very happy. Yeah. There you go.
it's actually that nice where it's in paragraphs.
At the coming. Okay, let's see what you got. Symbol, color, value.
Oh, yeah.
Letters.
Decreasing power.
Okay, so there's another one, okay? Keep going. How close are we?
How long is your
We could do it which one's like the best one.
throw it in the garbage, put it on your butt? Are you gonna have to check?
It would be the same because the royals are which ones are the greatest. Same thing as.
Ones we like.
Well, if they were.
You know about
Oh, these are actually a lot of That's why they have the cut corner, so that they can't be used anymore.
We've got like glitter on them. How many of them sort of alphabetical order?
Even if I face.
Like this one has but then
Oh, wait,
wait,
wait.
are they all that way?
It's okay, do it, do it, do it. She sees it.
I thought you meant this one.
What?
What about?
Got ruined the foil choice. You can't play with them if they're recorded.
Ace, two,
This one.
three, and then
This one's the only one. Race.
yeah,
Because you can have an A on the clock.
You stole my watch, okay? Don't steal my watch.
Other ways that we can.
over the watch.
You know they're not to tell me though.
Yeah, get over Because that's numerical. Your eyes.
Put all the same numbers together.
When does she look
Pictures were determined by school.
Yeah, it's about time to like.
Okay, how about we make number value, so like,
Let's see.
go A's, but
If
then
you spelled my name wrong too.
actual hard value for play on.
That's sad. King ace, we can do an ace instead. I was like, T-E-Y.
Yeah,
T-E-Y. That kind of T-E.
like a play value.
Ace isn't a card race, low card.
No, but we can make that like this numerical value. But if you're actually playing it.
Sounds like it's not a I think I care. I
You
don't.
know what I mean?
No, I don't. That's why you're.
Okay, everybody, we're going to have you start coming back to your tables, I mean to your desk, and we're going to move on with the lesson. Bring your list. Go ahead and leave the playing cards right there on the lab bench.
I suddenly wanted to grab someone and then start like all romancing, and I was like, why is this happening? They're I don't know.
You're welcome.
You don't get your pencil back.
But I don't know if I can.
Don't get sassy, Donna.
I just got
I'll trust these.
Okay.
Yeah.
So we'll have, who wants to be a scribe? Who has good handwriting? You don't? Riel?
She does.
Would you like to help out?
Don't let her lie.
I'd appreciate it. Here. Okay, So what we're going to do, whoever has the list, we're now going to go, okay, let's see, we have one list here. Everybody with a list that your team has made, go ahead and raise your hand real quick.
Wait, what?
Whoever is holding the list, raise your hand. 1, 2, 3, 4. Wait. There, 5. Okay, awesome. So what we're going to do is we're going to go clockwise and starting over here. You're going to list off one of your things. And Riel's going to write it on the board. And no repeat. So we're just going to keep on going around until everybody runs out of things that they can add to it. So what's the first way that we can organize it?
In suits.
Okay, so same suit.
This guy's wearing a suit.
S-U-I-T. Wait. Yeah. Wait, no.
You know what the
Yeah.
suits are?
No E.
No, I don't gamble. I want to learn how to.
Okay, so same suit?
I don't know.
Is that the same
Yeah, I
symbol?
will determine.
No, symbols can actually be different. Okay, symbols.
I can teach you as well.
Over here, color. Okay, so we got color.
Evens and odds.
Odds and evens. Evens and odds. I don't know, I always think that the odds should come first. Because it's 1, then 2. But then I guess you have 0, but. Well, yeah.
Okay,
Just do one.
damaged from undamaged cards.
Okay, so there were damaged cards and undamaged cards, that's true.
That's clever.
Okay, now starting over again.
By numbers or numerical order.
Okay.
Okay, so numerical order. Okay, so from smallest to greatest. Okay,
The designs.
designs. Well, we already have symbols. Oh, what do you mean by design?
Like the designs on the buildings.
Oh, the designs on the pictures themselves, like what weapons they have, what flowers they have. There we go. How many of you have noticed that? That some of the kings, they have different weapons, like one had a battle axe while 2 of them had swords and the fourth had a dagger. So there are differences in design. What's another one? Okay, over here.
The marked. The marked in the corners with black.
Okay, yeah, a couple of them were marked in the corner.
Letters, like separating the letters from the numbers.
Okay, so putting all the ones with letters, like aces, kings, jacks, queens, putting them all to the side, so letters.
What? Oh.
Just pick one.
Well, I don't know. Or black to red. Oh, that's I don't know which one because they all. I color
Face.
Yeah, it looks great. You're doing great.
Give that one.
They didn't do the face.
Okay, well, ones that have faces and ones that don't.
Okay, yeah.
Thanks, Brad.
That is different from letters. I mean, because with the letters you include the aces. With the face cards, you exclude the aces.
Group numbers.
Okay, group numbers. So group them by numbers. So not numerical order, but grouping them all aces together, all 2s together, all 3s. What do we have next?
Group them by faces.
Group them by faces. And do we got anything over here? Poker hands. Oh, okay. So like Full House and Royal Flush and all those. That's good.
Clever.
That's very clever. Okay,
Ones we like the best.
ones we like the best. Okay, yeah, we could definitely do that. Which one do you like the best?
Faces.
Me too. I was like,
Okay, what do we got over here? Does your group have any more?
oh yeah.
Oh, yeah.
So many.
We have a lot. With value.
Okay, so what do you mean by value?
Like when you're playing poker, right?
Yeah.
There's
Okay,
like
so the values in poker. Okay. So poker values.
Group by smiling faces?
faces.
Oh, okay.
I don't look for faces.
Okay, got another one?
Should just drop it his face.
Rows and columns,
Rows and columns. What do you mean by rows and columns?
like set them in rows, but
So you can organize them
yeah.
by numbers and by
Do you mean have like all red, black, going down and ones,
Yeah.
twos across?
So like solitaire style. Okay. Rows and columns?
I think alright.
No more? Okay, we got the first one out. Red, black, that's what kind of colors?
Like alternate.
That's kind of rows and columns.
Oh, I thought you meant those like, on, you know how there's like a diamond, or like that.
Oh, okay.
You can do that.
Alright. Do you have any other ones? Or was that your last one? Okay, above 10, below 10. That's a really good idea right there. That's a good concept. Okay.
By decreasing value. or
Okay.
increasing
Isn't
value.
that
Well,
numerical?
we got numerical right there.
Straights. Or I guess that's personal. I guess we're done.
Okay.
Are you sure?
We got the second one out.
Those with fantastic clothes on.
You got another one?
Yeah. How about solitaire style?
They have solitaire.
Yeah, we kind of include that in with rows and columns. You got another one?
I know, one with hair.
Who's that one
They
hand?
just don't have hair.
Oh.
The one? Oh, Van White.
That's me. How about like cards that you like and the cards that you don't?
They already
We
said
need to
that.
see
Is it really?
Yeah, might be up there.
That was a mind bar. I'm so glad you listened to me.
Well, yeah.
Okay, real quick, does anybody have one that they would like to add?
Yeah, we
Okay.
still have a few that we
Yeah,
have.
we have a few.
Yeah,
Go,
it's just
go.
from our age, it's cute.
We have 15.
Cards that we've worn and cards that we haven't worn.
That would be damaged.
Yeah.
Bill, how proper are you feeling right now?
Keep it in a big pile.
Okay, so just random order. Yeah, that's one way to organize it.
Is that organized?
Technically, it's all in one place. So just the fact that it's a card and you're putting them all together, that is organizing it.
By gender, because
We were going to there.
Oh, there we go, by gender.
That's
That's
clever.
That's what I said.
What?
By
Okay,
gender.
anybody have a last one? Otherwise, we'll move on.
I don't think Karen said.
I just said that.
Well, there's the queens and then there's the jacks.
There's red and black.
Okay, those with hair and those without hair, because the queens and the kings have hair and the others do not.
Okay,
You're
we'll
getting
put that one
feisty.
down, and then we'll call it good.
Coming a stretch.
Yeah, well, we're reaching our.
I think it was a
limits
stretch
of
when we said
creativity.
ones
But I
without
saw a
personality.
lot of good ones. Well, all of these are really good. Okay, so
Here.
there we go. Okay, so you guys came up with a lot of great ideas. I'm really surprised. I'm really happy to hear all this because what you basically were doing was that you were going through the process that the early scientists went through when they were trying to organize the elements. They basically had all these different elements with so many different characteristics and qualities and everything, and they were trying to figure out the best way to organize it. Let's see. Turn off the light. Okay, so what is an element? Not this. How many of you recognize this movie?
Honest guy.
Anybody recognize that?
Yeah.
Yeah, Iron Man 2. Okay? I can't tell you how I was feeling when I saw Iron Man 2 and I saw him just creating this element in his garage. It's not that easy. Okay?
So you were upset.
I was a little upset. He made it look so easy when it's not really that easy. You just can't make an element out of nothing. Elements actually exist since basically since the creation of the Earth, since the creation of the universe. These elements they come from stars. They're created there, but these elements are just lying around, and we now have the opportunity to organize them. So let's go ahead and turn on the light real quick. But yeah, so we found out that with the elements that there's different things that we could use to characterize them. What are some ways that you think we can characterize the elements?
Hardness.
Okay, hardness. So going along with geology, yeah, there's definitely some elements that are harder than others?
Smell.
Smell?
They have smells.
You thinking of any in particular?
Like, smell, is it sodium? Yeah, sodium gives off the smell.
Sulfur.
Sulfur,
Sulfur.
that's what I was thinking.
Yeah, sulfur has a very noticeable smell. You can tell when there's sulfur around, especially if you've been up to Yosemite. Yellowstone, there we go. I'm from California, so I want to say Yosemite, but it's Yellowstone. Any other ways?
Color.
Color, gas, solid, yeah, whether it's in air form. Compound set of forms. There are so many different ways that we can organize the elements, just like we've organized these cards. And so that's what we're trying to get to. And so if you could turn off the light real quick, Ms. Reed. Thank you. Okay, right here I have a list, or I have a couple different samples of different elements. Here we have palladium, we have potassium, platinum, silver, fluorine, oxygen, sulfur, aluminum, chlorine, carbon, bromine, silicon, nickel, iron, copper, iodine, sodium.
I thought carbon was a gas.
Carbon dioxide is a gas. So sodium and gold, which is AU. So just looking at this, can anybody group some of them together just from looking at this and from what you know of the elements? Are there some groups that you can make maybe of 2 or 3 of these elements?
16, 14, 26, and 79 is also.
Okay, so 16 is sulfur, 14 was,
Silicon far right now.
oh yeah, there we go. So sulfur, silicon, and then which other one you said?
26 and gold.
26 and gold. Okay, 26 is iron, gold. Okay, so being solid at room temperature, that is definitely one way that we can organize them.
Iron, gold, and silver, and platinum, because they're all metals.
Okay, iron, gold, silver, and platinum.
So is copper.
You can even include copper in there. And there's also palladium. You can also
Nickel.
include that. So metals on nickel, there's a nickel. So we got all the metals. Any other way?
Shininess?
Shininess?
Yeah.
Yeah, definitely. I mean, sulfur's not really that shiny at all. I mean, it glitters a little bit, but compared to gold and copper and silver, not at all.
Potassium, non-gold.
Potassium? Yeah. Okay, so potassium's in the group 1. Is there any other ones from the group 1 elements that we see here?
I'm just kidding.
Potassium, and then we got sodium right there. So those are both alkaline metals. Those react very explosively with water.
Wait,
It's
so if I
actually-
put water and make an explosion?
Yeah, so like the thing with sodium and potassium, they show them here in a jar because these are actually stored in mineral oil so that water doesn't come in contact with them because otherwise they'll explode. And it is really cool when it happens, but it's very dangerous.
Talk about that in the semester.
Like fluorine, and bromine,
Oh, there you go, yeah, fluorine, bromine, iodine, chlorine. Those are all halogens. Those are all in the group 7 of the periodic table, which we'll go over. And they're all in the gas form. And they have very similar properties in the gas form as well. Any others? Then we'll go ahead and move on to the next activity. But yeah, so as we can see, just by looking at these, the early scientists, they looked at these and they saw, hey, there's a lot of these ones that have similar things in common. And we actually look at the periodic table. And so there was actually a guy named Mendeleev. You'll probably remember him if you've taken biology. He was the one that did the Punnett squares, the Punnett squares. There we go, the Punnett squares, using the pea pod plants and showing hereditary and all that. But he also made a periodic table. It's actually called his periodic law. And he has here listed basically all the elements that were known at that time.
Wait, do the question marks mean that you didn't know what it was?
Exactly. he knew that there was an element that existed, and these numbers right here, these are actually the atomic numbers. Okay, so this is the number of protons and the number of protons in an atom, and he knew that there was going to be an atom with 45 protons that hadn't been discovered yet, but somehow he knew. See, that's one of the great things about his periodic table. See, there's a couple other spots, like there and there and there. So
He just guessed.
he just,
You didn't know to assume.
he assumed, there we go. Because he saw a pattern in this. See how we see like a pattern, 11, 12, 14, 16, 19. And so he didn't get all of them, but he was able to organize them in a fairly efficient manner. And so this was Mendeleev. And he organized them primarily by the atomic mass. Well, yeah. No, by the atomic number, sorry, the atomic number, which also has something to do with the atomic mass. So we'll move on to the next one now. Now behold, the periodic table. You've probably seen it all over the place, but now let's just talk a little bit about this periodic table. Let's see. So if I want to go back,
It's a pain.
yeah.
That's easier. One more?
Yeah, one more, that'd be great. Okay, there we go. So we see that we have here the periodic table. Now, what are some things that you notice about this table and the way that it's made?
Colors.
Yeah. Well, what do those colors mean?
There's like metals and non-metals.
Okay, metals and nonmetals.
Solids, liquids.
That's really good. So we're going to notice a trend. When we put the elements in this order, we notice that there is a distinction between metals and nonmetals going along on that. Over here on this side, with the exception of hydrogen, okay, hydrogen is just, hydrogen and helium, they're just the odd ones. But over here, all these guys, they're metals. They're considered metals. So if we look here, we see that these two are alkali metals, alkaline earth metals. Then we have our transition metals, which is this big chunk in the middle. Our poor metals, and these ones, like aluminum, we'll see that they're not the best of conductors. They're not that useful for conducting electricity, but they're still metals. And then here, we have nonmetals for the most part right there. Now this one doesn't really show it that well. But in between the metals and the nonmetals, just so you know, there's actually a class that's called metalloids. Now, I say between nonmetals and metals, but why? Why do I say it's metalloids when it's between metals and nonmetals? What can that possibly mean?
They turn into non-metals at a certain temperature.
That is pretty good, yeah. So under different conditions, these substances right here, you'll recognize silicon. Silicon is one of the big ones. It's this line right there, like this transition line right there. But under different conditions, like silicon's not the best conductor under some conditions, but when subjected to different temperatures and pressures, it becomes a great conductor, and we use it a lot in our software for computers and such. So over here, our periodic table is mostly metals with some metalloids right here, and then the rest is all nonmetals. And you recognize most of the nonmetals. Here we have carbon, nitrogen, oxygen, fluorine. Those ones are fairly common, and you come across those.
What you need to go to.
Yeah.
So, is fluoride?
Fluoride is actually, you'll learn about that later on when we talk about ionic compounds. But fluoride is a fluorine atom that gains an electron from another atom. So you'll learn about that further on. But yeah, fluoride is related to fluorine. Any other ones? Any? Think that?
What's the question, or what's the difference between alkaline metals and alkaline earth metals?
That is a really good question. So alkali metals, we see that they're a lot more reactive. They are super reactive with water. Whereas alkaline earth metals, they tend to lay back a little bit more. And so,
More down to earth.
yeah, they're more down to earth. There you go. Hence alkaline earth metals. You can use that connection. So yeah. Yeah, you can look up videos on YouTube for sodium explosions where they'll drop like a chunk of sodium into a lake, and it's really cool. Now let's just focus on one of the columns of the periodic table. So this right here is a column that I took from our periodic table. It's and who would like to list off the elements that are listed there?
Copper, silver, gold, and it's different on that one, but
Really, Gerium. Yeah. Don't worry about that one. I don't know why I put that one. Okay, copper, silver, gold. What do you know about those elements? Conductors. We use them as conductors. What do we use these as conductors in? Electronics, yeah. So pretty much everyone's cell phone has a lot of silver, has some pieces of silver in it, because silver is a really great conductor. And then most of our computers have gold in them. And then pretty much all of our electronics, all the wiring, we use copper. And so we see that in this column that they're all conductors. And we've seen that when we organize them by this, when we organize them in the periodic table, we see elements with the same conductors, or the same characteristics and properties lining up. Another thing to note about these ones, I don't know if you can see it that well, but here we have the numbers of the electrons in each shell. So you remember the 1s2, the 2s2, 2p6, 3s2, 3p6, 3d10, all those. Here we have the number of electrons in each shell, and so the copper has full shells, and then in its last shell we have one electron in its last shell. Same with silver. Full shells, I mean, yeah, it has one extra shell, but in its last shell it has one. Full shells, last shell it has one. Full shells, last shell it has one. And so we see that these properties are also related to the electron shells and how many electrons are in the outermost shell, the outermost sphere. We have also here the noble gases. Who remembers from last time what we used the noble gases for?
Simple configuration.
She's using a shortcut. She means a shortcut.
Yeah, the shortcuts for the electron configurations, that is very true. And we use those because if you look here, in the last shell, 2, 8, 8, 8, 8, 8. So all these have full outer shells. And so we're able to use them for that. Another thing to note, contrary to what a lot of people think, these noble gases actually have mass. Like neon, it has an atomic mass of 20, etc. and so forth. So all the gases actually do have mass. So what I would like to do now, we're going to go ahead and, we won't turn on the light just yet. But I want you to break off, or you can do this by yourself or in groups, and using any resource that you have available, you're going to look up and find 4 properties of any of these elements that make it good for what it's used for. For any of them. So I tried to pick different kinds of metals, and also a metalloid. Here we have a metalloid. But I want you to, real quick, I'm going to give you 5 minutes to do this. Okay? So pick one, and using any resources, use your books, use the internet, use your phones, and look up and find 4 properties that make your element unique, and also find out something that they're used for. And when the time's up, I'll ask a couple of you to share what element you picked, and you're going to share with the class what you've learned. So, do you need light? Okay, so go ahead and pick one and research.
Wait, so we research gonna need to find out what you think about it, and maybe then another element?
Yeah, for certain things. So like, some metals are better conductors than others. Some metals are lighter.
Can we compare one to another one on that list?
You could, or you could just research the one and then write down 4 properties of that. Yeah, if you could write it down, that would be great. Just write down your 4 properties.
With the ability for the iron to be bonded into different alloys, would that be one of the properties?
That is a good property right there. Yeah, being able to mix, to form alloys with other chemicals, with other elements.
Alloys are considered solutions.
Yeah. Everything makes sense.
Solid solutions.
Did anyone pick tungsten? Sweet. Huh? It is in light bulbs, and it's also an industrial metal. So
It's also right here.
yeah, same here. So both the rings that I use, my wedding band is actually a tungsten alloy. It's tungsten carbide. And what I like about it is that it's a very durable metal. It won't bend, really. It won't scratch. And it's awesome. I can bang it against furniture and it won't do anything to the ring. To the furniture, it's another story, but yeah. Compared to other ones. So it's pretty expensive compared to what? So iron is just pure alloy. Exactly. And there's plenty of carbon. Do any of you have like a favorite element? You probably never thought about it. Helium. Yep, helium is really fun. There's so you probably definitely tried inhaling helium if I'm not mistaken. Don't worry, I do it every time, every chance I get. But did you hear, what is it? It's
So it's the portion of
I want to say it's like sulfur hexafluoride or something like that. But it's a super dense gas, very non-reactive, but it has the opposite effect. It makes your voice deeper, and so to hear a woman inhale the sulfur hexafluoride and see her just starting to speak with a bass voice, it's hilarious. You should look it up. It's look for the gas that's opposite of helium.
So a use of ours is that it prevents chemicals from reacting.
It's sulfur hexafluoride.
There you go. Whew.
I remembered it, that's awesome.
Thank you.
I'm gonna look up videos about him.
Fridays.
Don't watch them right now, but in your off time, it's really cool. Like you could even float like tinfoil boats on this. Like you'll have this box full of nothing, and put a tinfoil boat, and it'll just float.
But you should not inhale it, because it's really bad for you.
And she said.
Because it fills up your lungs, so you can't breathe
You gotta be
anymore.
very
Like,
careful inhaling it. Yes.
Is helium bad for you?
Well, I mean, because it's you're inhaling helium instead of oxygen. So yeah, you gotta do it in moderation, otherwise you won't get enough air to your brain. But it won't react with anything. Carbon monoxide, that's dangerous.
It was, what makes you dry ice.
Yeah, there you go.
And I heard the story once that, like at a party, somebody thought it'd be really, like a pool party, somebody thought it'd be really funny to throw dry ice.
Okay, who feels that they have enough, who got their 4 properties?
Wait, 4? I don't know.
Okay, who has at least 3 properties, or 3 random facts about their element? Okay. Well, which one did you pick?
We did gold.
Okay, we got gold. Tell me about gold.
Do you want to say it or do you want me to? So it's the best conductor of electricity,
Okay.
and because it is, they use it in electronic devices like cell phones and desktop, laptop, computers. They also, the gold allows phones to stay free of corrosion, and dentists also use gold for fillings for your teeth.
Yeah, so gold corrosion. Okay, other metals corrode, they'll break down, but gold, you see a gold coin from thousands of years ago, it looks the same because it doesn't corrode, it doesn't react readily with the air, so that makes it a great quality, especially if you have it for filling.
I did iron, and it's hard, malleable though, so like they can change and bend and stuff. What was the other 2? It can bond with other metals, so you can make alloys like steel out of it. And I had another one, and I just forgot what it was.
Can you magnetize it?
Yeah, I can.
So there's another quality right there.
Oh, and a conductor.
There you go.
Tungsten, and it has the highest melting point of any of the metals.
Yeah.
It's used in filaments and incandescent light bulbs, and then it's usually like a light gray or it's whitish, and then if you make it into tungsten carbide, it is an extremely hard tungsten. You can use it like drill bits.
Yep, or rings. Jewelry makes really nice.
I did chromium. It's used to like harden, like make stainless steel and harden things, and it's also used to tan leather. And we take in about 1 milligram a day because it's in our feed
There you go. So yeah, these metals also serve as vitamins. I mean, iron also is something that we ingest. I mean, we don't eat pieces of iron, but we ingest small particles that's in our food. Same with chromium. Anybody else really quickly want to share what they found out? No? Okay, so did anybody look up lead? No? What about silicon? Okay.
Is it pronounced silicon or
This one is silicon. So silicone actually has an E at the end, and that's the stuff that you get in a tube. So yeah, this is silicon.
I thought they were the same thing.
No. Silicone has silicon in it, but
I think it's base properties.
yeah, it uses silicon as its base, but silicone has other stuff mixed into it. So that's good. But yeah, basically we see that all these different elements, they have different properties. Some are better to use in spaceships, others are better for using in drill bits, and et cetera and so forth. And so what I'd like you all to do now, because it's almost the end of class, we're going to have a quick assessment. Okay, I want you to get out a piece of paper. Yeah, I'm sorry. I have to do this to show that I can give an assessment. But really quickly, I just want you to answer these questions. You don't need to write down the question itself. Just write 1, your answer, 2, your answer, 3, your answer.
This is your exit ticket, so
So the first question is why did Mendeleev leave gaps in his periodic table? The second one is what do elements in the same group have in common? And there's different answers. So if they're in the same group, they're in the same column. So what do they have in common? And then name a metal, a metalloid, and a non-metal using the name and symbols of the element. So you're gonna, let's see. I'm trying to think how we're gonna do this, because you don't have access to the periodic table.
They have periodic tables.
Oh, you got your periodic tables, perfect. So yeah, go ahead and look at that. Metals, non-metals, and a metalloid. And just another piece of trivia about tungsten. You can't tell tungsten is actually one of my favorite elements. But tungsten, its chemical symbol is W. And the reason for that is because it's originally called wolfram in German. And so tungsten is wolfram. So, yeah. Small trivia that I don't know if you'll ever need to know, but if you ever hear somebody say tungsten, yeah.
No, I was gonna do thing, but I was looking it up, and there was one thing that said like the military was using it for like kinetic bombardment, so they would like drop it.
Oh yeah. I mean, tungsten is such a hard metal.
Reminder, the following students come to the attendance office. Trace Potter, Abigail Carlos, Claire Sidaway, Jay Schooling, Savannah Hughes, Shalani Hughes, Tyler Grover, Angie Acevedo, Kylie Bradshaw, Christian Bjorn, Isabel Gordo, Braxton Harrop, Sonia Hernandez, Matthew Jenkins, Brenda Linhart, Chase Maines, Cesar Morales, Dawson Murray, Jonathan Garcia, Ortiz, Wes Russell, Nakai Whitewright, and Jarrett Alvarado come to the attendance office.
Yes, put them on the book on your way out.
Okay, thank you everybody. Have a great day. Have a great week.
Hey, is it okay if we use the periodic table in the back of our book?
Sure. That's perfectly fine.
Yeah. Metal, non-metal, and metalloid. Thank you.
Could I have Hanson Curtis please come to the main office?
I don't know.
Also, another reminder, teachers, please during your prep, make sure that you go to the library and check with the American Fidelity representative. If you cannot do that today, if it won't work out your schedule, he will be here again on Friday. I have a sign-up sheet here in the main office. You can stop by and fill that out. If it is your prep, please check with the American Fidelity. Thank you.
Where did I put this?
He is in the library in their conference room.
You are so gracious. The most gracious sort of graciousness.
You are, or?
You are. So let me use I think a little sassy. Some might say gracious and one would sassy.
I thought it was block I almost fell.
And we are done, and we collected the assignments over here. They're on the corner desk. And awesome.